Hi, ladies and gentlemen. I hope everyone is doing well today. Today we are beginning our Unit 8 note packet on reactions. We start with intro to chemical reactions. So right up front, the first two questions are a review on naming. So remember, we already did a naming review in class. Refer to that flow chart you took down as notes. Will be helpful when you're thinking about naming. So next we come down to chemical reactions and what they look like. Okay, so now we're done focusing. So right here is your chemical reaction. Right here is also a sentence. The two reactions, the reaction and the sentence, go together. So I kind of highlighted to help you pull apart. So pull apart the reaction into the sentence. So we start with the name of the first reactant. So remember, reactants will be on the left side of the arrow. So you have copper nitrate, copper 2 nitrate. Remember, it's a transition metal, so we need the Roman numeral. Next, we have reacts with. Reacts with is the same as the plus sign. Next, we have zinc metal. So remember, it's reacting with zinc. Remember, everything on the left side of the staircase is a metal, so we can safely say it's zinc metal. Next, we have and yields. You could say forms, you could say combines, or you can just stick with yields every time, just like the note packet does. Remember, that's the arrow. And then next, we have the two names that are in pink. We have zinc nitrate and copper metal. Remember, copper, we can say it's a metal because it's on the left side. We assume everything on the left side is a metal. And then and goes with the plus sign. So that's kind of how a chemical reaction is. You could be given a chemical reaction in with symbols, and I can be asked you to write the sentence, or I can give it the other way. I can give you the sentence and ask you to write the symbols. So the next few questions are actually all about this. So I will do the first one out for you guys. Remember, if you need help with naming, to refer back to that flowchart. I am going to kind of assume that you know these are the names. So if we're looking at question 3, we have CaCl2. We know that this is an ionic bond, so it is calcium chloride. Remember, it ends in "ide" on the periodic table, negative ion, so we change the N into "ide." So then we have calcium chloride reacts with, because that's what the plus sign means. Now we need to see what this is. This is silver nitrate. So again, look up the ionic bonding rules on your flowchart. And then after that, remember, we have our arrow next. Our arrow symbolizes and yields. And then we just have to name our two products. Our products are on the right side. This one is calcium nitrate. And the plus side symbolizes and then we have silver chloride. So again, we just followed our ionic bonding rules. I'm sorry, I guess that got cut off a little bit. So if I make it so it fits, we have calcium chloride reacts with silver nitrate and yields calcium nitrate and silver chloride. So remember that we use nitrate because it is a polyatomic ion. So next, 4, 5, and 6 are all similar. Use the words to go to the symbols, or use the symbols and go to the sentence. So next we have some information on reactions. So kind of like a little bit of the form, a little bit of the language that needs to be used. What everyone should do is, so instead of highlighting and writing all the words in the margins, I figured that I would just show you guys the definitions on the front. I guess I need to zoom out a little bit. So right here, everybody should pause this, copy down the definitions. They will be very helpful when you are answering the next few questions. One thing I did want to point out, though, about reactants and products is, so remember, reactants are what the reaction starts with. So it's what's on the left side of the arrow. Your reactants are always on the left side. Products are always on the right side. Products are always what's being formed. Next, I want to address this paragraph. So if you do notice that stuff isn't equal, it's okay. We are just going to practice generating the reactions, and then after that we are going to move into balancing and making sure that everything equals each other. And then lastly, I wanted to talk about diatomic molecules. So diatomic molecules means that a substance always needs to be bonded to something. It never wants to be alone. Elements will bind to themselves, so they don't end up being alone. That is what you see up in this example. In this example, it is H2 because hydrogen is part of our diatomic molecules list. So this would be a good time to say that this is your diatomic list. I always remember it as Brinkelhoff, just kind of like a silly word, silly mnemonic to remember, help me remember which ones that cannot be alone, they need to be bound to themselves. So anytime you have bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, or phosphorus, and it would be alone, you need to write a 2 instead to symbolize that it's diatomic and it binds to itself. So that information will be helpful when you're answering these questions. Remember, reactants on the left side, products on the right side. Next, we have some information on single replacement reactions. So you may have already wrote this down when I paused the video the first time, but a single replacement reaction is a single atom that replaces an ion in a different reactant. So we can look at these two examples right here. So if we read what it says, a single atom replaces an ion. So we know that this single atom silver, this single atom magnesium needs to replace one of these ions, one of the other ions in the reactant. One thing I will tell you is that the positive ions will switch places. So silver has a +1 charge, magnesium has a +2 charge. In this case up here, potassium has a +1 charge, chlorine has -1, calcium +2, fluorine -1. So then as you can see in the first example, silver and potassium switch places because now it's potassium alone and silver is bonded. In the next instance, again, the same kind of thing happened. The magnesium and the calcium switch places because now you have calcium alone and magnesium is bound to fluorine. Excuse me. When you combine the elements, so after they switch places, you need to remember to crisscross. So remember, silver has a +1 charge, chlorine has a -1 charge. So then when we crisscross, it does become AgCl. Remember, we don't have to write the ones. And then in the second case, we did need to make sure to crisscross magnesium and fluoride. So then the 2 goes there and the 1 goes there. So then that is how we get MgF2. So now question 9. So question 9 and 10 are very similar to each other. So I'll walk you through number 9, base what I do on number 9, base what you do on number 10 off of what I do on number 9. So in this case, Na and Mg, why can't they be produced? So remember, we can go through and label the charges. So sodium has a +1 charge, magnesium +2, chlorine -1. So remember, I wrote that the positive ions switch places. So Na-Mg can't be produced because Na and Mg are the two atoms that need to be swapping places. So they are both positive, so they both need to swap. So then next, why can't NaCl2 be produced? So remember, Na has a +1 charge, chlorine has a -1 charge. Don't forget the Cl. So then remember, when we crisscross, we write the numbers that we see. So it would be NaCl. In this case, sodium would have to have a +2 charge, which it does not have. And then lastly, given our answers to parts A and B, do we think that sodium chloride and magnesium are the only products that can be produced? In this case, the answer is yes. They are the only products that can be produced, and they are because there's no other positive ions for sodium and magnesium to switch with. There's no other positive ions that can switch. So now base number what you do on number 10 off of number 9. Question 11 is a little bit of a review. So it's just writing the chemical equations from the names. So go from the names, remember reacts with its positive, produce or yields is the arrow, and then use the names in between. Question 12. So question 12, they follow a similar pattern. So remember, I already told you the pattern as the definition. So remember, the pattern that you always see is that the single atom always replaces a different reactant, an ion in a different reactant. The positive ions always switch with the positive ions. So then lastly, question 13. So question 13, remember, so these are just a couple examples of reactions. Remember to determine the charge. So the first thing you need to do, I'll do out 13A, so base B and C off of A. So the first thing is to identify the charge. Sodium has a positive 1 charge, chlorine has a negative 1 charge, silver has a positive 1 charge. So I'm sorry about the focus. Remember, sodium positive 1, chlorine negative 1, silver positive 1. So I'm just letting it focus, trying to let it focus. All right, so just bear with me while it works. So we identify the positive ones. So sodium and silver are the two positive ions. So remember, they are going to switch places. So then we know that sodium is going to be alone, and that we know we're going to form an ion with silver with a positive 1 charge and chlorine with a negative 1 charge. And now we crisscross. Remember, when we crisscross, the ones come down, so that just becomes AgCl. So when you do B and C, do the same thing. Identify which ions are going to trade places, and then when they trade places, remember to crisscross. Remember, if you have any questions, please circle them, write down your question, and bring them to class. I hope everyone has a good day.